In this example, I'm going to show you how to multiply two decimals together. So in this case, I have 1.4 and I want to multiply it by 0.5. Now, the commutative law is really important in this particular situation, especially if I want to do this conceptually using these grids. Sometimes using the grids can add more confusion than is necessary. When we were using the multiplying by a whole number, it can be conceptually simple to understand, but sometimes using the grids can be a little bit difficult to understand. I would suggest that in a situation like this, it's a lot more efficient to use the commutative property and rearrange this to have 0.5 times 1.4. Now you want to encourage the students to be able to do this as well. So you want them to use the most efficient method. Now I can use 1.4 times 0.5 and work on this grid and get the same solution, but it will take a little longer and it would mean chopping and changing a lot of things. So I'm going to start off with the 0.5. Now I'm going to again suggest that you use the fractional language that we discussed, especially when operating. So remember when I, in a previous video, when I was talking about fraction operations and changing the language, so multiplication represents of. So I want to look at that in terms of. So if I say 0.5 of 1.4, it can be a little bit easier to conceptually understand. Or even if we know that 0.5 is a half, we can say 1/2 of 1.4, and that will also be a lot simpler to understand, especially if you start getting familiar with fractions. Now, if I was to use the grid to do this, I would start off with 1.4. So I would start colouring in my 1.4, because remember, I want to take 0.5 of 1.4. So when we are multiplying decimals or fractions or any number, even whole numbers, if I had 3 times 4, I would take 3 groups of 4. All right, so we're starting with that second number in our group. So I'm going to make my 1.4, so obviously it's my whole. I shade in all of that. 1 whole is 100 over 100. And then I want to take my 4, or my 0.4. Now, if I was to do this with my students, I would get them to rewrite this decimal in its fractional parts, and preferably its expanded fractional form. So you could rewrite this as 14 tenths multiplied by 5 tenths, like that. So I've got another 4 tenths or 40 hundredths to colour in. And this is where a very similar situation to fractions comes in, where I want to take a half of this, or 5 tenths of this fraction or this decimal. So here I've got 1 and 4 tenths. I want to take 5 tenths of these two. So what I'm going to do is I'm going to, so now 5 tenths of the whole thing, obviously, of both of these wholes is going to be this. But really you only want to use whatever the crossover is. So altogether we've got 5 tenths and 20 hundredths. So 5 tenths is the same as 50 hundredths. So we've got 50 hundredths and 20 hundredths together. So if we add these two parts, we're going to get 70 hundredths, which is 0.7. All right. Now, this may be confusing to a lot of people. Some people will need this to be able to establish a conceptual understanding of decimals, but I like to reserve it for those situations where we really need to deeply understand what's going on in this system when the fractions or the decimal fractions are not working. Okay, so start off with a simple version. As I said, start off with showing the students what's actually going on in the multiplication, and then move into what I'm about to show you here. So I'm going to rub this board off. All right. So if we've got 1.4 and we want to multiply it by 0.5, I want you to change this into its decimal fraction, because that's what that actually tells us. Then I want you to perform the same method that you would use to multiply fractions, and simply just multiply the numerators and the denominators together, because by the time students get to this stage of multiplying decimals, they should be familiar with fractional multiplication. So what this would be is 14 times 5 and then 10 times 10. 14 times 5 is 70 and 10 times 10 is 100. So 70 hundredths is 0.7. Very, very, very straightforward. If you were to use the method that is traditionally taught in secondary schools or all schools, that is to look at the number of decimal places in each one of these factors. Here we've got 1 decimal place, here we've got 2 decimal places, so we've got 2 dp to start with. Now we would ignore the decimal, 14 times 5, perform the whole number multiplication, 70, and then they talk about bringing the decimal place back in, counting 2 decimal places. Now I've got a lot of issues with this. One of those being that the decimal place doesn't move when we multiply and divide by factors of 10. It's the digits that will move up and down a decimal place, but the decimal point does not move. So we need to stop referring to the decimal point as being moving. Now this is very similar to the method that I showed you when we were multiplying by whole numbers. It simply does not add any context to anything that's going on. It's another method that we need to remember. It's another method used that students don't understand, but linking it back to fractions, which is really just using one method, the same method for performing 2 different types of operations.